formwork and other materials. When it comes to construction, uh, concrete, as we know, along with steel, is the most consumed material. What we say on this planet after water, concrete is the second most consumed material. Okay. And also, concrete also is the most sustainable material compared to aluminum, steel, wood, glass, and many other products. The reason behind this is made out of limestone and available at economic costing compared to any other material. Apart from that, when we are using cement, cement is consumed all over the world close to 4.3 billion metric ton, out of which India is the second largest producer of cement. In that cement, we are closely producing up to 450 million tons every year. The moment we talk about sustainable green materials for construction, the concrete itself, the embodied carbon is close to, in the building construction sector, close to 11 to 12%. So we need to work on reducing the carbon footprint in the embodied carbon space, because construction and the building maintenance together contribute about 30% of the total greenhouse gas emissions globally. Globally, the emissions levels are close to 50 billion metric ton every year, carbon dioxide. So I'd like to go to the slides as quickly as possible and also keep on explaining how the construction green materials play an important role for sustainable construction, for futuristic India. We are talking about Vikasit Bharat by 2047, and we are talking about net zero by 2070. These are the various goals of government of India, and each and every state has their own benchmark in reducing the carbon footprint. So how we can conserve the natural resources, utilize the byproducts, and make use of the technology to develop new alternative products for sustainable construction. So I don't want to spend much time because hardly have any time. So we need to look at sustainable construction, sustainable architecture, 3D printing, BIM, artificial intelligence, and what are the future trends, and also have a concluding remarks. So background, as I already told you, each and every ton of cement used liberates about close to zero point 0.8 to 1 ton of carbon dioxide. We continue to build the space because very important, more and more concrete jungles are being formed, whether it's Mumbai, Bangalore, Hyderabad, Delhi. Current, the Indian population is about 35 to 40% in the urban environment and balance is rural. In the next 10 to 15 years, there's a huge migration moving to cities because better opportunities, better facilities. Because of that, the population will be close to 50% of the total population. So as we urbanize, we are going to have adverse effect, flooding, heavy rainfall, and lack of sanitation. These are the various things. The challenges we are going to face as the world population come from the current 6.2 billion people to 9.8 billion people by 2050. Most of the people are going to be centric towards Asia, Southeast Asia, India, Pakistan, Bangladesh, then we have Indonesia, in China. China population is decreasing, but other cities in Africa, the populations are growing, creating more and more urban jungles. So we need a sustainable solution. So there's a scarcity for food, energy, land, because look at the Mumbai. I think yesterday, Hyderabad, I think some 7 acres land was sold for 167 crores. So like that, the land is shrinking for the construction activities or any development, because land cannot expand. We can grow fruits, we can grow vegetables, we can manufacture any product, but land we cannot manufacture. So as the construction activity increases because of the development of metros, highways, expressways, airports, tomorrow the inauguration of Navi Mumbai airport is going to happen by Honorable Prime Minister Narendra Modi. These are the various developments, the drivers for the future growth. And at the same time, when we look at the building materials which are being part of the construction, cement and steel contribute to about 12% of the total emissions of total carbon dioxide emissions. So we need to really work very closely how we can develop infrastructure including construction, houses, buildings. So the building space, operational carbon is about 28% and building materials space is about 11%. So we need to mitigate. Okay. So how we can mitigate? Using sustainable technologies, because cement industry, as we know, it is continuing to grow from current 450 million tons. By 2030 it will be about 800 million tons. The cement consumption is going to go up because India is still the lowest consumer of cement per capita. So as we continuously improve our infrastructure, the developmental things are going to happen, and more and carbon dioxide emissions are going to happen. We need to control that. Currently India, close to 73% is the blended cement. In that, most of the cement are PPC cement and slag cement. Now LC3 cement has been introduced now. Okay. With these innovations and technologies, as we progress, India need to adopt technologies, innovations in building material sciences, adopting high grades of concrete, high performance concrete, ultra high performance concrete to reduce the thickness of the concrete elements so that we can save on concrete, reduce the carbon footprint. So there are various ways. Resource requirement is more for sustainable development, and we need to really conserve the natural resources. In that aspect, we need to really work very hard. As we see more and more tall buildings, which are the benchmark of Western world, now India is also now coming to the main landscape of developing major super tall structures. Mumbai, we see every day new projects are being launched, not less than 60 floors, 70 floors, 100 floors. So with this, materials are required, and as I told you earlier, concrete is the one product which is having lesser carbon footprint compared to aluminium, steel, glass, reinforcement, timber, other things. So we need to really work on this. So emissions are going to be there. India and China are going to contribute a lot, and we need to really work on that. So we need to make concrete with lesser carbon intensity. How we can make that? Utilizing various options. See, we can use low carbon concretes and develop low carbon concrete using technology, innovations, and admixture science by using SCMs, secondary cementitious material like fly ash, silica fume, GGBS, and other materials. We can use slag cement, calcined clay cement, and we can use PPC cement, recycled aggregates, as my previous speakers were talking about, using recycled aggregate. Steel slag aggregates, CND, where JSW is also front runner in developing new technologies for aggregate sciences. At our steel plants, we want to utilize all our byproducts of steel manufacturing to valuable products. So, the philosophy of JSW and hallmark of JSW Group is to work very closely with nature, developing technologies, working with our byproducts. So because we generate a lot of slag, we generate a lot of fly ash from our manufacturing process of thermal energy and also steel manufacturing. Using these products of the group company's strength, JSW Cement has developed very, very important green products. As we stand today, and the global carbon footprint, I'm talking about the cement production, I told you 4.1 billion, and the average per ton cement CO2 emissions in India is 580 kg of global average of 580 kg. Indian average is 529 kgs, and JSW is able to manage around 220 kg. So very important. These are the various aspects. I want to go a little bit faster. We have the paucity of time. Sustainability is very important. How we are going to give as economic benefit to the society, making social impact and conserving the natural environment. Okay, should be bearable, equitable, and sustainable. So green buildings are the solutions. There are 10 ways, best way of construction using technology. We can do all the resource mobilization to achieve sustainable construction practices by 3D printing technology, using big data analytics, building information modeling. These are the few precast technology. So there are no new technologies available where we can reduce the carbon footprint by advantages of technology and science. So how the future of construction will be in 2070? So future of construction by 2070, most of the construction will go for high grades, from low grade M20, M25, M30 grade to M60, M70, M100, M150 become quite common. So as we increase the grades of concrete, the technology, fiber reinforced concrete technology, self-compacting concrete technology, 3D printing, and various things are going to come and help the construction industry to develop sustainable building solutions. So architecture, future of architecture also, many architects now they are going green. Whatever the projects they're designing, they are going with a perfect landscape, perfect design, perfect ecosystem using green building materials, specifying specifications with the IGBC certification, LEED certification, BREEAM certification, and GREA certification. So new technologies upgrades are very much important, and using the low carbon materials are very important. So going vertical is the solution now, because as the cities are shrinking, most of the population would like to live very near to the public transportation system like metros, like suburban metros and other transport mechanisms. So we are going to give more and more vertical. So starting from the uh, prescriptive based mixed design system to performance based mixed design. Prescriptive is something about M20, M25 regular grades of concrete. The performance, they will specify the performance, RCPT value, what are penetration and what are permeability. All these new things will come. Chloride resistance, sulfate resistance. These are the various things. So engineering the concrete becomes very important. To engineer the concrete, we need sustainable solutions. Sustainable solutions like using high range admixtures to reduce the water content, to increase the performance of concrete, and increase the strength of concrete, and also adaptation of SEMs, more and more SEMs in the concrete behavior. So these are the various SCMs available. So we have supplementary cementitious material like fly ash, slag, calcined clay, many national. So new housing technologies which have been adopted are also helping to achieve sustainable construction practices. In that we have drywall technology, we have shear wall technology like my one former, which is being adopted in major cities now, because there nobody is going for wall to wall construction. They are all adopting formwork technology. High-rise buildings are becoming quite common nowadays. Precast technology is coming up. So when these technologies are coming and more new machineries are also important. My previous speakers have spoken about new machineries and technologies, new concrete making machines, new block making machines, new bitumen making machines. They are very important actually. Mass housing projects are there, light gauge steel construction, 3D printing, which is now taking a very big importance now all across the country. Many IITs are doing a lot of research work on 3D printing technology, 3D printed boards. All these things are quite common. So you can see using mud also you can print it. So when you develop an ink in 3D printing, you can use various alternative materials. Sand, you can use natural, or you can use artificial sand, slag sand, you can use slag cement or PP cement. Various things are available. So coming to the construction, already I've told you why concrete is very important and why sustainability is very important in concrete making, because we need to reduce the carbon footprint, embodied carbon in the construction, because concrete is almost utilized for everything. Earlier, people were all talking about slab, beam, column, but now even for wall structures, take any high-rise project like Prestige Brigade, Puravankara, Lodha, any big top builders, they are all using my one formwork. They are not using any block work and all. So, in this case, the centering or the formwork play a very important role. Okay. So sustainable concretes are important, using admixtures are very important, and also following the IS code. IS code is also getting revised now. The new IS code revisions now, lot of alternative materials can be effectively utilized. Okay. So why there's one product called GGBS, which being manufactured by JSW, which can replace cement up to 70%. That's very important. Based on the application, raft foundation go up to 65%, marine structure 65%, then PT slab 35%. Like that we can use. Why GGBS? Because it will bring down the CO2 reduction. When we use pure OPC cement, the carbon footprint per ton is about 850 to 950 kg. When we use GGBS, it's about 60 to 80 ton. So straight away it will reduce the per cubic meter carbon emissions by almost 42%. So also it is a double reactive product. It reacts double, converting calcium hydroxide to CSH gel. That is very important for the hydration process. It gives enhanced performance, enhanced strength, durability, lesser cracking, improved resistance to sulfite and chloride attack. So I've done a small calculation using 40% GGBS you can really design the concrete. Various, let us say, I have a small project, you can save equivalent to 1,050 trees. Okay, so then for every ton of carbon dioxide saved now, it's equivalent to planting 50 trees. Okay, benefits of this product: best durability, best architectural values. And blended cements also taking very much shape. Blended cements are being used extensively in the retail segment and also in the project segment, like slag cement, like PPC cement, LC3 cement. So many cements are there. This is very important. And also, these are the various products of JSW Group. We have ComCem, a blended composite cement, which is highly durable and performance giving. And compared to the OPC, there's a lot of comparison. Already I've shared the PPT with the B2B magazine. You can all take this presentation. Okay. Then the concrete HD, there's one more cement, which is slag cement, highly durable. This is a slag cement used for marine structures. So these are the advantages. So the climate change activity, like you take the cement OPC, 0.95 tons per ton of every cement. If you take GGBS, it's only 60 kgs, it's only 0.25 tons. Like that, when you take the blended cement, okay, the impact on the environment, 142 kg greenhouse gas emission, 50% GG for replacing 85.4 kg, 30% fly ash, 118. So how we can reduce the carbon footprint? For one grade of concrete M30, by using higher percentage of GGBS, we can reduce the emissions close to almost 42 to 50%. So there's a certification available by JSW called EPD certification, Global Warming Potential. So many certificates we can always share and are available in the social domain. Go to our website. So JSW using technology, using materials, using our byproducts, we are standing ahead of any other company in terms of overall CO2 reductions. So that's why JSW has been named as the global benchmark in cement manufacturing in reduced carbon footprint. Many certificates are available. These are some of the projects where we have been approved: Shobha Brigade, government projects, Bangalore Metro, Bangalore International Airport. Tomorrow, the inauguration is happening for Navi Mumbai Airport, where JSW award, they have received the IICA Sustainability Award for Innovations and Technology. Today only it got announced. So Bangalore International Airport, T2, Terminal, the taxiway, expressway. So 3D printing also, we are working very closely. The IIT, Govt, they have done a lot of work on 3D printing technology available. Coming to JSW Group, as a big group into various operations: steel, cement, paints, energy, sports, automobiles, and ventures. Many ventures JSW has started, and cement also is having all India presence. We are going to start one more plant at Rajasthan of 4.2 million tons. With that, we'll be covering North India also. These are the portfolio of products of JSW, starting from cement, concrete, GGBS, microfine GGBS. We have the new range of construction chemicals. So we are ready to serve any project requirement, any small requirement. So major customers, we have all the government agencies, projects, info companies, RMC plants, and major IT companies. So moving towards net zero is very important. As we progress, construction industry has to move using technology. Technology is one side, materials are one side. So using sustainable green materials, innovative products, innovative technology, state-of-the-art machineries. My previous speakers have spoken about machinery. It all have to come together. Then only we can achieve success. Using green hydrogen, using the vehicles, electric batching plants. So these are the new way towards moving towards green and sustainable constructions. Okay, so cementing a new concrete future is very important. Using sustainable materials, sustainable technologies, sustainable specifications, we need to really work and move towards that. So would like to conclude with my presentation by saying that B2B purchase is a very good platform where they bring in people from the manufacturing of raw materials, manufacturing of machinery, technology, all them together in a single platform. We are teaching the whole world that how we can build sustainably, efficiently, economically.